My name is Twan Altena and I am an application engineer at De Hoek van Kerosi. We can look at how the machine is set up. The electrode or cathode is fixed to the z-axis, which is equipped with an oscillator. The electroder has the negative shape of the profile which we want to project onto the part. The anode or workpiece is clamped to the table. An electrolyte needs to flow in between the workpiece and electrode in order to conduct the electrical current and to flush away any dissolved material. The flow of the electrolyte is controlled by a flow chamber, which makes sure that we have an optimal flow underneath the electrode. The electrode will move down to the workpiece with a set speed. During this, the electrode will vibrate with a set frequency up to 90 Hz. During this vibration, the electrode will move 0.2 mm up and down. When it's at its lowest point, the electrical current is applied in order to dissolve the material. On these three pictures, we can see the process which takes place during the oscillation. We can break the process down in three main steps. We can see the movement of the electrode as the line which follows a path as indicated by the sinusoid line. At step 1, the electrode moves down to the workpiece and the working gap is open. At the second step, the machining gap is closed and a current pulse is triggered, which triggers the electrochemical process. This causes the material to dissolve. At the third and final line, the electrode will move away from the workpiece, which allows the flow of the electrolyte to flush away the dissolved material. I would like to thank you for your attention and interest in the PECM technique. I will hope to see you later at De Hoek. Goodbye.